Welcome to Part B of Digital Electronics. In this video, we will dive into two fundamental sequential circuits, the SR flip-flop and the JK flip-flop. As a quick recap, a flip-flop is a memory element that stores one bit. It is the core building block for sequential logic, where the output depends on both current inputs and past states, controlled by a clock signal. The SR flip-flop, or set-reset flip-flop, is the most basic architecture. It uses two inputs, S for set to 1 and R for reset to 0, and produces two outputs, Q and its inverse Q. This block diagram shows the basic structure: two inputs, S and R, a clock input, and the two outputs, Q and Q. S sets the memory to 1, and R resets the memory to 0. The SR flip-flop truth table is straightforward. 0, 0 inputs result in no change. 0, 1 resets to 0. 1, 0 sets to 1. However, the 1 input creates an invalid condition. S equals 1 sets the output to high. R equals 1 resets the output to low. S equals R equals 0 holds the last state. The invalid state occurs when S equals 1 and R equals 1 simultaneously, which is a logic crash because the circuit tries to set and reset at the same time. The JK flip-flop is considered the enhanced version of the SR flip-flop. It completely solves the S equals 1, R equals 1 crashing issue. It uses inputs J and K, which act like set and reset, respectively. The JK flip-flop block diagram looks identical to the SR version, but with J and K inputs. The internal logic is where the smart upgrade lies, preventing the crashing behavior. In the JK truth table, J equals 1 and K equals 1 no longer cause a crash. Instead, this state introduces the useful toggle feature, which inverts the current output. J equals 1, K equals 0 sets the output to 1. J equals 0, K equals 1 resets it to 0. J equals 0, K equals 0 holds the memory steady. Crucially, the J equals 1, K equals 1 input is the toggle state, flipping the current output perfectly safely. The key difference is that the SR flip-flop has an invalid state, while the JK flip-flop resolves it. The JK flip-flop also uniquely supports toggling, making it suitable for universal applications like counters and registers. Flip-flops are essential in digital systems. They are used in binary counters for timing, memory units for static RAM operations, and in sequential logic design for building finite-state machines inside microprocessors. In real life, SR flip-flops are used in simple control systems, like a water tank control. JK flip-flops are perfect for digital clocks and frequency dividers, as they need the reliable toggle function for counting. To summarize, the SR flip-flop is the basic memory block, but it has a dangerous, invalid state. The JK flip-flop is the smart upgrade that resolves this issue and adds toggle support, vital for counting and sequencing. For a quick revision, the SR flip-flop is for direct set/reset control, but you must avoid the 1-to-1 state. The JK flip-flop is the universal upgrade, where 1-to-1 safely performs the toggle magic. Thank you for watching this video on the SR and JK flip-flops. We encourage you to keep learning and keep growing your knowledge in digital electronics.